Water flows in a pipe with a pitot static tube attached to it. If a deflection of 50 mm mercury, here, deflection, is noted on the manometer, calculate the flow velocity of the water in the pipe. What is the volume flow rate in the pipe in liter per minute if the diameter is 120 mm? So based on the previous example that I have give the formula for the velocity when using the pitot static tube and also manometer, we will apply it into this question. So the problems looks like the previous example. So we have the manometer attached. This is your point 1 and also point 2. Then this is the manometer. The deflection is 50 mm mercury is noted on the manometer. Okay. Okay. And the diameter is 120 mm. So this is the diameter of a pipe. Okay, in order to solve this problem, we can use the previous derivation and come up with the formula for the velocity when we using the pitot static tube and also the manometer. So from the previous formula, we get V equal to 2GH rho m over rho minus 1, and we got the square root all of this parameter. So in this case, we will get the velocity at point 1 here. Okay, then we just put the value that we know here. For example, here the deflection of the manometer is represented by h, which is equal to 50 millimeter, or we convert into meter, it becomes 0.050 meter. Then the density of the mercury is given as Sg of the mercury times rho of the water, which is 13.6, and also the density of the fluid basically equal to the Sg times with the rho of the water, is 1, and then we just put into the formula here. So your velocity equal to the square root 2 times g 9.81 times h 0.05. Then you multiply with the density of that mercury over 1000 minus 1. Then you square root all of these terms. So now it becomes 3.516. meter per seconds. So this is how we want to calculate the problems regarding on the Bernoulli. Then we apply into Pitot static tube with the manometer. Okay, after we got the velocity at point 1, as the question asks for the volume flow rate, we need to use some formula to relate the velocity and also volume flow rate. And this can be related by the volume flow rate V dot equal to area times the velocity. So at point 1 here, we need to use the area at point 1, but the area of this pipe basically is a constant value with a diameter of 120 millimeter. So we just put the value here, the area pi times diameter square over 4 times V1. So what we will get is pi times diameter is 120 millimeter, or we convert into meter, it becomes 0.12 square over 4 times V1, 3.516 meter per seconds. So the unit that we will get is meter cube per second, because the unit for area here is meter square. So the value becomes 0.03977. And then in order to convert the unit into liter per minute as the question are required, okay, so in order to change that, we use some dimensional analysis here. For 1 liter basically is equal to 0.001 meter cube. We can use as 1000 liter per 1 meter cube here. And then in order to change from second to minute is 60 seconds for 1 minute. Okay, so now it becomes meter cube, this is second, we will get the unit in liter per minute. So your answer is 2386 liter per minute. Okay, that's all for the example of the Bernoulli equation using the Pitot static tube with the manometer. We will go for the next video after this.